Okay, and John's presentation today is going to be Civil 3D modeling tips and tricks and hacks, the super simple stupid surface tricks edition. That was a mouthful, John. This session is going to cover how simple tin surfaces can assist with Civil 3D designs, calculations, and plans. John is an engineering technology manager for New Leap Energy. John is an expert elite charter member and has been working with the Autodesk products for over 25 years on site, utilities, drainage, transportation, and flood analysis projects. Welcome, John, and we're very excited for your presentation today. Take it away.
Thank you, Christina. Thank you for having me. I'm honored to be here in such incredible company. But I have a lot to do, so let's get right to it. I'm going to share my screen. And here. All right, so this is the Civil 3D modeling tips, tricks, and hacks. This super simple, stupid surface tricks edition. Here's my bio. We're going to move on. This is not the important stuff, but I'm an engineer. I've worked on a lot of projects, and I've been using Autodesk software since the last century. Some of our objectives is going to be a fast and furious 40 minutes aimed at demonstrating how simple Civil 3D tin surface can be used to assist your civil engineering design tasks. We're going to talk about blending surfaces, filling surface holes, simple surface uses, flattening feature lines with a zero surface, and profile and section projections with surfaces. There's about 30 minutes of videos here, and I had to use videos to keep the time constrained, so let's move on. If you're watching, hopefully you have a good understanding of AutoCAD and how to create and edit Civil 3D surfaces and feature lines. This demonstration is 100% unadulterated Civil 3D. No additives, preservatives, or add-ins have been used. So we often get surfaces and we have a survey, and maybe for hydrology, they need a larger area. For geological studies, shadow studies, I've always needed to blend surfaces on a number of projects. It's really a very simple method. And in the old days, we used to actually connect contours with polylines and trim them. It would take an hour. Here is a summary of the procedure. And let's dig into our first video and get right to the demonstration. All right, this is hopefully
there we go.
Quick tip on how to blend surfaces together without going around the old days and drawing contours, right? And then trying to get all these contours to line up. So as we see, if we just paste these surfaces together, the result is not that great. And as you see in blue, we get a lot of contour stacking because the border of the good surface does not meet at elevation at every vertex to the larger outer surface. All right, and here you see in 3D a lot of the jagged results as well. And we just want a better blend, and this is really quick. I display this inner surface, the good surface. This was acquired from a survey doing a field topo. I make sure there's a border showing, and I use from the contextual ribbon the extract objects command, and I bring the border into the drawing as a polyline. Yours may come in as a 3D polyline or a 2D polyline. In your modify design dropdown, you can convert, or you can use the stepped offset command on a 3D polyline or the offset command on the 2D polyline. But I'm going to offset a distance of 50 feet to create a transition area. And I'm not worried about the elevation at this point. I'm going to note real quick that this polyline that I just created leaves my surface, and I want to get it fully on the surface to make sure I don't get any errors in this. And there we have it. Now the border is entirely on the outer surface. I'll get a blender a better blended area, and I'll get elevations on these vertices. I'm going to take that 3D polyline or 2D polyline, and there it is, and I'm going to use the assign elevations, and I'm going to assign elevations from the larger, the outer surface, and I'm going to insert intermediate grade breaks to make sure that I get a vertice everywhere the tin crosses that blue line. And there we have it. It converted into a 3D polyline. It came up to elevation. And I'm going to take this inner one and erase it. I don't need it. Now to create this transition area, I'm just going to simply make another surface, a temporary surface. I'll call it EG transition. And I'll change the style so I can see it a little better. And what I'm going to do with that surface is first paste in the smaller surface. And rebuild it, of course. And then what we do is we just simply add this new border to that surface as a break line. And then because of the excess triangulation I'm going to get in this area and this area, we're going to take that same 3D polyliner and add it as a boundary. 3D polylines will perform better on this than feature lines, and you don't have to use or edit these lines. So a lot of the feature line tools are not going to benefit you. So use the 3D polyline because it will perform better. But you can see now as we go around, all these contours are lining up perfectly. All right, so let's turn that one off temporarily and that one, leave that. And now let's make a final surface, EG final. And let us paste in the larger surface and then paste in the transition surface. And there's the results. No more stacking contours all around the site. They look a little better. And again, it's just a look. It's not an actual survey in that transition area. But if you're using this for hydrology or shadow studies, geological studies, this may help. Let's zoom in and look at that area right there again. That looks a little better, right? Okay. All right. This is hopefully so that's video number one. Tip number one, quickly blending surfaces. And if I go back to my PowerPoint, here we have another common trick I do with surfaces a lot is filling surface holes. Surveyors don't like to show dirt below buildings and other obstructions on site. And we often get surveys that are delivered with holes under buildings. I get them under containers, equipment, and that can be a problem if you need to do demo in the site and show contours. If you need to run volumes in the areas, you're not going to get results where there's a surface hole. And if you're trying to daylight, you're not going to find any solution to your daylighting there. So let's take a look at. All right, you've got a surface. Here is a surface delivered by a surveyor, and it's got some holes. The holes are going to be a problem if you need to daylight to those areas, or if you need to do volume calculations, and if you need a contour plan for demolition, you may need to fill in. So let's look at that really quick, and let's just assume that we want to demolish this entire site. And actually, we're not demolishing the containers. There should be a surface under there. The surveyor just put a hole in there. This is easy. Quick, simple solution. Right-click and, or not, edit your surface properties, or somehow use your properties or quick properties to change the style to show borders. And then extract the borders from the surface. Let me unload that X reference. Contextual tab lights up, extract from surface, extract objects, extract the borders, and there they are. I can change my surface back to contours and I can see it. And I do not need the outer border, so I'll erase it. But with this, all I need to do now is make a new surface, call it EG Demo, or whatever you want. And if we just paste in the existing surface and take these polylines, and there's no elevations, they're just 2D polylines at elevation 0. You can look under the hood, they're right there. We can just add them as show boundaries, not outer boundaries, show boundaries to the surface. And there we have a site that we can now grade to or depict as demolished. And if you wanted to clean up contours, you could use a couple of polylines, flip some triangles, do what you want, but there's the quick and simple solution. All right, let's go one step further. What if the main building was staying and we were only going to demolish the garage? The easy fix for that is just to model the floor of the building and let this fill in, and the surveyor was nice enough to provide us with some elevations. To accomplish this, it's really pretty simple. I'm going to use NC, and I'm going to bring in that polyline. I don't want that one. I want the inner one, not that one. All right, I got them both. I used the nested copy command, brought them in as a 3D polyline. And let me just trace over this one to get it in quick for the dividing line, right? This is where the buildings will divide. Isolate those layers, and this is a 2D polyline. Good. I'm going to weed that just to get rid of some of the, and I can use, even on 2D polylines, a lot of my feature line commands. All right, so we got that cleaned up. I'm just going to run BO and get a boundary inside here, and I'm going to offset that 0.05 units to the inside to give me a polyline for that floor elevation I'm going to model. And I'm going to get rid of that other one on the outside. And I still have now this boundary here. And I'm going to unload the XREF. Now this is in our surface, e.g. demo. And because I just performed that operation on it, I removed it as a boundary. And that's good. I want that. I don't want to rebuild yet because I want elevations inside here. This is the dividing line. And I'm going to use features from elevation or feature elevations from surface and get elevations from the demo surface, the one that goes through here on that. And you can see that comes up to grade where the demolition surface is. I'm going to take this inner polyline and I'm going to give it the elevation the surveyor sent us. You can see that moves up to grade. And with this feature line, I'm going to get elevations from either surface. It doesn't matter. They both have the elevations I want. I am going to take these 3 polylines, 2D and 3D, and add them to the surface as break lines. I don't have to worry about mid-ordinate distance. I have no curves. And there we go. There's your demolition condition. And the nice thing about modeling the floor is it hides all the contours between the small horizontal offset you have. And even if you reload your existing conditions, if your buildings print with a width, you won't see the contours at all. There you go. All right, so that was tip number 2, handling demolition and using, again, some simple surfaces to help you get through your projects. These are not necessarily full grading methods. I'm not teaching how to design a road or anything here, but the idea of this is just to see that there are a lot of uses for putting simple surfaces together, and they can be put together very quickly. Simple polylines can be used for simple surfaces, and I have used simple surfaces for creating detention basins without infills, with gratings and corridors. I have used them to project buildings, bridge decks, water surface, underground structures, stormwater structures to profile and cross-section views, computing water surface volumes, creating HEC-RAS sections with pre-modeled flow obstructions from the buildings in the surface, and for globally flattening feature lines. And let's just look at simple surfaces here for a second, because we make surfaces and we kind of think of them only as being used for an existing topography or a proposed topography. And there are... All right, so let's take a look at simple surfaces. We think surfaces, and the first thing we think of is an existing ground topography or a proposed ground topography when we work with Civil 3D and civil engineering industries. But a simple rectangle, all right? You know, even if I just make a surface out of that, it becomes a plane. And I don't know if I'll ever really need to model a plane, but think about water surfaces. Maybe you do, especially when you're talking about detention basins, right? If you model a water surface, it's very easy to get a volume, especially if you have irregularly shaped or stacked surfaces. And I'm not trying to make excuses to get away from the stage storage command, but limiting that one surface might help limit and ease that stage storage command as well. Let me change my visual style over here to conceptual. And right, so we've got a surface, it's a plane, right? And it's nothing major, it's the polyline. So I offset that 0.05 units, and I'm going to do that because I am going to raise this a ½ a foot and add it to the surface as a break line. And that plane, well, now it's an equipment pad, a concrete pad, you know, a gravel pad if I send it down. And it's just a couple of polylines, and it takes seconds to create. That's the big idea to get across here. The surfaces are very stable, simple to create, and don't always need to be an existing or proposed ground topo. Now, here's a little off-topic tip. Again, another simple, stupid surface trick, but if you use gratings a lot and you use infills, and you notice that when you move stuff, a lot of times those infills disappear. And it can be problematic if you're getting automatic volumes and you don't realize that hole is there, but you're not going to get volume calculations through there, right? So if you want to avoid that, when you do your gratings, just simply take all of the feature lines created and add them to your own surface. Let's make a new surface here, call it basin. Hit OK. Let's give it a mid-ordinate distance because we have curves. And there's your basin. And if I set it to auto rebuild, and if I pick it up, I'm never going to lose. And of course, always move only the bottom one, let the gratings follow. But I can take it and I'm not going to lose that infill. Even if I rotate, it's always going to stay with you. All right, so more stupid surface tricks, but again, those surfaces don't always need to be an existing ground topography. There's a lot of other uses for them. One of the big uses, I've often have needed to convert survey figures or feature lines to polylines, and we didn't want to lose the arc segments in those. And when we explode feature lines or survey figures at varying elevations, you will get chorded 3D polylines where those arcs are. Let's look into our next video and see how we can use a simple, stupid surface to flatten a whole bunch of feature lines. All right, so the task is to get all of these feature lines out of this drawing as 2D polylines, and we need to retain all the curves or the arc segments in those polylines. So how do we do that? Well, a simple surface is what is going to do it for us. This will be the zero surface. And the zero surface is nothing more than any rectangle or polyline surrounding and fully enclosing all of the objects you want to flatten. You create a new surface. You call it zero. You don't even have to name it because you're going to get rid of it in a few minutes. And you add that rectangle or that polyline, which should be at elevation 0 in most drawings. The elevation command is set to 0. Add it as a break line. And I'm going to show you the problem is that if we just explode these feature lines, we get 3D polylines as the result, and the arc segments are lost. And that is because there are varying Z values across that 3D polyline or across that feature line. If you explode a feature line that has a constant elevation, you'll get a polyline with the arc segments and not the chorded 3D polylines. And that's where the zero surface comes in, because we can, and warn, either make a copy of your drawing or don't save this, because once we flatten all your surfaces, if they are set to auto rebuild, they're going to change. So check all your surfaces or don't save your drawing, one or the other. The corridors are probably fine. But definitely check your surfaces and make sure they're off. And what we're going to do is go to our Modify tab. We're going to go right to the elevations from surface. We're going to choose our zero surface. We're not going to insert intermediate grade breaks. At the command line, we're going to use the multiple option. We're going to hit return and we're going to assign elevations right from that zero surface. Everything is down at elevation 0 now. I can explode everything and I can either copy it and paste it, but these are all polylines and all my arc segments are preserved. Okay, another simple trick to help with just some common tasks that I've found in my workflows. One of the best things about these simple surfaces, and one more thing about flattening feature lines and survey figures. There's supposedly a trick where if you use a survey figure style that shows the elevations flattened to an elevation of 0, that if you explode them, you'll get the curves, and it doesn't work. So this may help you with your survey figures in particular. All right, back to the simple surfaces. The best thing about these things is they project into profiles and cross sections so well. And if your alignments or your sample lines are moving, you're not going to have AutoCAD objects to update. So here I'm going to show you how to take these simple surfaces, build a few more, and how to use them to get projections into your profiles and cross sections. All right, we saw how to make simple surfaces out of polylines, and you can use feature lines and many other things, but a lot of their uses that I find practical are really in projections. And that's because if we project objects or 3D polylines that are parallel and, linear, they work pretty well. But if they're closed and wrapping around or, around the alignment, they don't look too well. And here we're going to see, here's a linear object. We project it to the profile. And there it is. It's right on the surface. I can move it up. And you can see it. And it works fine. But if we have something like this fence that we wanted to project into all these sections and the alignment, I would make it a 3D polyline. And for now, let's start with getting this polyline leaves the proposed grade. So it needs elevations from both the existing and proposed. And instead of making a surface and pasting them together, I'll just do this operation twice. The first time on the larger, the EG. All right, and that converts it to a 3D polyline. Oop, let me do that again and put it on the existing demo. And I'll get all the elevations. And then if I run it again on the proposed, it'll only modify the elevations on the proposed surface. So that polyline, that 3D polyline, which is right there, will now project onto both. And if we do, in fact, project that to this profile, use the same style, that's really not what we're looking for if we wanted to see the fence in the profile in the sections. Surfaces are a great way to take care of this. We already have this as a 3D polyline. That would represent the bottom of the fence. I would use my stepped offset command. I go 0.05 units to the inside and give it an elevation difference of 8 feet for the height of the fence. And yellow is a horrible color. Let's change that to magenta. And there we see top and bottom of fence. If I take them and add them to a new surface, now I don't need to see this in 2D, and contours aren't going to be of any use. So I'm going to give this a style that hides the surface in 2D and shows the triangles in 3D. I hit OK, and I add those 3D polylines as break lines. We have some excessive triangulation, so we take the outer one, the outer polyline, and add it as an outer boundary. And because our fence really isn't covering the site, we take the inner one, the inner polyline, and we add it as a hide boundary. And there we have our fence as a surface. A little tip, if you had a gate you wanted to accommodate, you could just draw another polyline and add it as a hide boundary. And you have an opening for a gate. All right, so with that, we have the surface, and now we all know that if I create a surface profile, that is going to represent the fence much better in projections. And another benefit is with projections in cross sections, you have to do them manually for each section. If you have a surface, you can project that surface into all of the sections in one shot, going to your sample line group properties and your sections tab, and sample that surface. And your fence will appear in all your sections. All right, we have our fence projected. We now have a gravel pad. What if we needed to get that into the profile and the sections? Well, we'd use the same process. But this one, I'd probably use feature lines. This is part of the design, and it could be much more dynamic. So I'm going to go and create a feature line. And this is the gravel pad. I have a separate site for it, and I can just use it by layer. I'm going to assign elevations from the proposed surface, and I'm going to make them relative to the elevation, relative to that proposed surface with a 0 change. And there's that feature line right up to grade where the gravel pad would be. And now I'm going to go to my stepped offset, and I'm going to again use a 0.05 horizontal offset to avoid any vertical faces in the surface. I'm going to offset to the inside with an elevation difference of -1 for the depth. And I'm going to take that inside polyline, and I'm going to go to the elevation editor, and I am going to make this relative to the proposed surface. At minus, all right, there's going to be relative to the surface on all of them, And the relative depth is going to be -1 foot. And there we go, we save that. And now, if the grading changes, if the site raises, lowers, I can have this just open up and automatically adjust to that. I'll take these two feature lines, add them to a surface. I'm going to add a new surface here for the gravel pad. Again, I don't need to see it in plan view. I'll keep it active in 3D so I can see it. And we hit OK. I don't have to worry about a mid-ordinate. I don't have any curves in the geometry. And I have a little excess triangulation again, but we solve that by using the outer feature line as the outer boundary for the surface. I can now select that alignment, create a surface profile for the gravel pad. And there it is. And I can also now go into my profile view properties, and I can use a cut hatch with a gravel style to show that. All right, let's take this a step further. And this actually happened, but what if the crazy request came to show all of that equipment, right? All of these guys and all the concrete pads in profiles or sections for whatever you're doing. Line of sight profiles, demonstrations for a municipal board or something. But again, easily done with those simple surfaces. And I have here two polylines on different layers, one representing the bottom of the equipment and the other representing the top of the equipment. And I did the same for the concrete pads top. And again, we use a slight horizontal offset to prevent any vertical faces from appearing in the tin. So there we have all those objects, and I did that prep work just to make this process easy, but we can very easily make a surface of all of that equipment and bring it up to grade and automatically project it all into these profiles or cross sections very easily and fast. So with that, I am going to take, and I used the layers, the different layers, so that I could continue to use select similar. And when I create feature lines from these, and we're going to use feature lines from these again to get some of those benefits that you get from feature lines, relative elevations from the surface. And we're going to put them on a new site called equipment. And I'm going to use one style for the top and one style for the bottom, because again, that's going to allow me to use select similar. I'm going to assign elevations. I'm going to assign elevations from the proposed surface, and they are relative to the surface at 0 feet. I want them right on the surface. And I click OK. Those feature lines come right up and you see it in 3D view. And that's all the bottoms. Now I have the tops, and I'm going to select similar again. These are the polylines. I'm going to deselect the smaller ones. They're at different elevations. I'm going to right click, go back to my create feature lines, put them on the equipment, and I'm going to give these again a different layer. This is the top of the different style. This is the top of the equipment. And we're going to assign elevations and make them relative to the surface by 6 feet for the height of the electrical boxes. I'm going to now select the remaining polylines and go back and create the feature lines. Again, these are the top. I'm going to use that style. And these will be relative to this proposed surface at 3 feet. I can then take all of these feature lines, if I select similar on both of them, right click, I only have feature lines selected, so I get these wonderful commands here. I can make a new surface, call it equipment. And again, I don't need to see this in 2D, only in 3D for confirmation. Click OK. And again, we've got the excess triangulation thing going on here, right? And it's even going outside there in the corner. So, and over in this corner. So what we're going to do is take a object we have that fully encompasses all of that, and I believe that that does. Oh, maybe not there. All right, so let's just draw a simple rectangle. We can put it on a good layer as we need. Topo dash border. Leave it on there. And I'm going to add that to my equipment as a hide boundary. And the equipment goes away. And then, because I use separate styles on the top and bottom, I can go around and select all the bottom feature lines and add them as show boundaries. And there's all my equipment. All right, so again, that's easily shown. We have all this stuff now. We can show this all very simply in profile by sampling surface profiles. And here we have the gravel pad. We just need to get the equipment in there. And there it is. And if we needed to get it into our cross sections, we could go at our sample line group properties and sample. Let's bring in the gravel pad and the equipment. And we can get all those objects shown in all the cross sections. All right, now I think the big benefit there comes from the number of times you expect revisions on your line of sight or alignments. You know, a lot of times when we draft in profiles and cross sections, we might start using AutoCAD objects, lines, polylines, and text. And if we do that and that alignment moves, you know, we're going to have to go back and adjust all that. And it becomes quite a bit of work in the revision process. The nice thing about using those surfaces is if you shift that alignment, all those profiles and alignments, all those profiles and cross sections are going to update automatically. If you have to add sample lines or move sample lines or delete sample lines, again, the sections will all be updated automatically. All right, so that's our presentation. Do we have any questions?
I think most of those have been answered already, John, in the Q&A.
All right.
No questions on your content. Everybody seems to love it.
Great. Yeah, if it was some old stuff, I hope.
Here we got one from Tom, John. Can
Okay.
you get a similar feature line to 2D polyline result from using the export civil 3D drawing command?
Not if it has varying elevations. If the feature line has varying elevations at the vertices, it will explode to a 3D polyline.
Thank you.
Yeah, there's a number of different tricks. These are just a few things that have helped me get through a lot of my work. Like I said, I've used these for, you know, showing bridge decks in profile that, you know, when the topo doesn't cover the bridge, floodplain analysis, and we do a lot of line of sight profiles for planning boards and municipal boards that want to see what things are going to look like. And these little tricks come in quite handy for that. All right, Todd. Well, thank you very much. Oop, new messages coming in.
Just getting a lot of praise. Here we got one from Sheldon. Any tips on shrink wrapping data to avoid interpolated data along the edges?
I am not sure which process. Is this with the blending surfaces?
Is that what the blending surfaces, Sheldon? No, surfaces from survey data.
If we're talking about like removing excess triangles or where there may not be enough survey data to fully define it, I would probably either use a boundary or remove triangles from that survey. In the design scenario, I'm often using boundaries. I'll always use boundaries to define the limit of grading. To me, when I do grading, that surface border is where the bulldozer stops, where the clearing stops, where the land use change stops. And in a lot of my work, that area is regulated. I have to report the area of it to see if I'm further regulated in other areas, particularly stormwater. But when it comes to that survey information, getting rid of excess triangulation, I've never really used shrink wrap. I've just generated a border for the survey.
So Chad has a question for projecting the equipment. Is there a benefit to creating surfaces versus extruding and projecting as 3D solids?
No, I just think that Civil 3D probably, and again, this could be my my thing. The tin surface is a Civil 3D object. To me, it would probably be a bit more predictable than using an AutoCAD object. They are, in fact, different tools, and AutoCAD really doesn't know about Civil 3D, and Civil 3D knows something about AutoCAD, but really not everything.
Very good. Any more questions? If so, put them in the Q&A.
And I do have a handout. I will pass this on to Augie. The handout goes through everything we did with a summary of the procedures and some screenshots and some tips to help you get through anything that you wanted to try.
Awesome. Got a lot of praise in the chat, John. So great job.
Thank you all. Hope to pass a little along.
Oh, we got another couple of questions here.
Okay.
What was the main reason for not exploding the survey figure?
There's no reason not to. I just, if they come in, a lot of firms that I've worked in, we never really printed those 3D objects. We never printed survey figures or feature lines. We always had a 2D polyline base map for existing and proposed conditions to go into our sheets. And with that, there was always a need to, again, bring them and convert them into feature lines or polylines without losing the arc segments. We wanted to put radii on, curve returns, stuff like that. And if you do explode, and you can explode the survey figures, but again, if they have varying elevations from any vertice, they're going to explode as 3D polylines rather than 2D. The tip I work with the zero surface will work on your survey figures as well too. Start a brand new drawing, import your figures, make that zero surface, assign the elevations, explode them, and you've got your polylines right there.
Awesome. Thank you.
Okay. All right, I did speed up my videos to get through them. I was hoping I had enough time for Q&A. I can definitely stop by the conference room after this too if there are any additional questions.
Very good. If y'all like to join John over in the lounge, he's there to answer any other questions, like he said. So thank you, John. Appreciate you.
All right, thanks.
Great
Todd,
job, man.
be good, bud.